Hello and welcome to another edition of CryptoKoryo podcast. Today we are again doing another interview about the AI narrative. So I'm very happy to have Greg Osuri, co-founder of Akash Network, today with me. Hey, Greg, how are you doing today?
Good. How are you?
Great, great, and great having you. Thanks for being here. So we're gonna cover the AI narrative, which is very trendy recently in 24, 23. A lot of projects coming, a lot of things to cover. But let's start with, about yourself. Tell us a bit about your background and how you came to DeFi and how you started with Akash.
So before Akash, I founded a company called Angel Hack. So Angel Hack is the largest hackathon-based accelerator in the world. I mean, we were responsible for making hackathons mainstream. This is back in 2013. Prior to that, I was a open source developer. I spent most of my life, professional life, as an open source developer in the container infrastructure and developer tooling arena. And at Angel Hack was where I got introduced to a heavy ecosystem, a large ecosystem of developers, about 200,000 developers right now in the ecosystem. We did hackathons all over the world. I mean, it was the company that launched several prominent companies. A big one would be Firebase that got launched at Angel Hack. There's several Web2 companies that rose to prominence launching at Angel Hack. Firebase, for those of you that don't know, is acquired by Google, became Google Cloud database. And so that's really where I identified a common problem amongst developers, and that happened to be deployment at scale, right? So when you are at a hackathon, you have an idea, you can quickly build that idea, launch it in a matter of days or even hours. But then if you want to scale that out to real users, that tended to be a challenge, both in terms of the technology landscape as well as the cost landscape. And that's when I discovered this new technology stack called Linux containers, uh, and found a significant use for these containers to solve a critical problem when it comes to deployment, right? Be it scalable deployments. And containers were widely used by Google back then, and Google was able to scale, call it the Google scale, because of containers. So I started off on a journey to bring this Google scale compute to the masses. That's how Akash was founded. And we, in the early days, as we were, you know, deploying this container native solution, um, ran into another product called Kubernetes. So Kubernetes, if for those of you that don't know, it is a container orchestration solution. I started contributing to Kubernetes ecosystem in 2014. It's one of the early people there.
Wow. Mm-hmm.
Overclock Labs, the company we work for, was founded to take Kubernetes to market. I mean, talking about a time when no one heard of Kubernetes or very few people heard of Kubernetes, and Overclock was one of the first companies to take Kubernetes market. So we're talking about that early. I've written some code for deploying Overclock that is open source now, and I've gotten some degree of prominence on GitHub, and my libraries were trending on top 10 on Golang. At one point, my libraries were trending above TensorFlow, which is a machine learning
Wow,
application by Google.
that's amazing.
And a lot of that work went into Kubernetes, HashiCorp Nomad, HashiCorp Terraform. All these are tools that DevOps folks use on a daily basis, and I've written my contributions are now part of that. And so, if you're using Akash, the source code for Akash is used by even Amazon CLI, as a matter of fact, right now,
So,
and still actively used by Amazon. And so that was the foundation for Akash, and that's how as we discovered, we discovered that most compute in these data centers are unused, right? North of 85% of compute when we're deploying our Kubernetes and container native solutions tend to be unused, and it was right around then cloud was getting extremely prominent in deployments. I mean, Netflix really showed what cloud can scale up to, and that started a new trend where every company, if you're launching, you are launching on the cloud. That was great in terms of capabilities, but disturbing in terms of concentration of power. That led to just misalignment of tooling. A cost was increasingly getting higher and higher. There's lots of research on. I mean, Andreessen Horowitz published an incredible paper on the $1 trillion paradox that talked about the cloud, how 50% of your online fee you pay for online services such as Netflix or Asana goes to a cloud provider. So all of us pay a cloud tax without realizing we're paying a cloud tax. And the idea of a super cloud was just getting formulated, mostly in the academic circles, but it was an amalgamation of ideas that, hey, if we can somehow create a super layer on top of the cloud providers that is decoupled from the cloud providers, um, in an architecture where the control plane is in the user space and the resource plane is in the cloud provider space. That way, we can enable any cloud capable computer to be part of this larger super cloud narrative or super cloud model. And we loved that idea. We immediately saw the opportunity because it was solving a very critical problem of consolidating different cloud providers into a single federated viewpoint. And we started our research. And when we wanted to do this, we wanted to make sure it's open source because cloud being closed source was setting a trend that applications were getting closed source, and we have it's reversing the progress we made as a society for open systems, and that was disturbing. So we wanted to make it open source, and that's really where we started looking at how do you create a sustainable model for open networks. Ran under Ethereum in 2015. We started experimenting and prototyping on Ethereum. We learned quite a lot on decentralized systems. We wrote a paper in 2017, published that, introduced the notion of a decentralized supercloud, and we predicted that the cost of the cloud is going to be on an uptrend unless something is done about it, especially for resource intensive activities such as machine learning. We have a whole paper on machine learning in our 2017 paper. We predicted about GPU costs and whatnot. And rightfully so, in 2024, you're seeing this problem uh, come out and seeing a lot of light on this problem, right? And now Akash is gaining the success that it has primarily because of our predictions, 8 years ago, essentially. So that's how we started into getting into crypto. We didn't really start off as crypto. We started as distributed systems,
Hmm.
trying to solve a problem with cloud and really, how do we create a marketplace that is open and sustainable? And if you look at any other models for crypto or for open source software in general, uh, all the successful companies that are open source failed, right? I mean, only maybe I'm sorry, I take it back. Successful companies that followed a typical traditional pattern that did not innovate in business models failed. A classic example would be Docker. Docker is the most commonly used container native solution, and they went in the traditional route of raising at $1 billion valuation from name VCs and eventually ended up selling the company for peanuts to an enterprise large company, right? So that sort of pattern was not something we wanted to follow, and we wanted to explore new opportunities and new business models. And that's really, I think, another side of crypto people don't talk about is the sustainability of open source. We see that with Kubernetes, and we see that with the contributor churn that happens in Kubernetes, and with most systems that are open and reach a level of maturity, you see the traditional models failing, and that's one of the more attractive parts of crypto for us. Now, if you look at Akash, has about 480 contributors. It has a public goods fund that funds development of Akash, and doesn't require a single company like Overclock Labs to continue the development, but rather an on-chain mechanism where anyone is eligible to apply for funding and get funded and whatnot. So, long story short, that's how we got started into doing what Akash is, and it's been a 10-year journey from the first time we wrote the code, the first line of code.
Amazing. A lot of things happening. One of the interesting points here is I've spoke to a lot of people, and many of them, when they come to crypto, it's kind of a pivot. So they were doing something, and then they realized that there is this decentralized thing, and they liked it, and then they pivoted to doing something new actually. But in for Akash, it seems with the background that you had and where you started in 2013, working in decentralization and in cloud and Kubernetes and containers, it's just a continuation of what you were doing before, and it was just a natural evolution of a problem that we were having, going through the decentralized way. So this is very interesting to me. That's super interesting.
And there's quite a lot of technical reasons as well. If you're happy to get into, if you like, but
Yes.
the blockchain as a structure for edge computing is also very interesting. In general, what open source model looks like is this, right? You have a piece of software somebody wrote, somebody open sourced it, and then you have contributors that either use the software and want to make the software better, or have some degree of commercial intent of using the software to build commercial products. Either way, you need support. You need people working on it. Only question is, what is the motive for the people working on it, right? And so initially, a lot of successful open source software is successful because people that use it want to make it better, and they only do that during their free time. Generally speaking, it's very very rare to see uh, uh, open source software getting picked up by companies and just being supported because companies feel like they should contribute to open source, right? So the motive is very different, and it has a high degree of variance. But if you look at something like Akash has, well, it's open source like Kubernetes and whatnot, but it has a organized uh, set of groups that maintain the software, and these groups get paid by proposing different improvements to the software and getting approved by the token holders. So the big difference between your traditional open source software and a decentralized open source software is who pays for the development and what is the incentive for someone to contribute. An engineer who is considerably very very expensive in terms of the time allocation. Why would someone contribute to a decentralized network, right? So so what well, if you look at Kubernetes right now, the top contributors are churning, they're leaving because they have lives, they have other things to do, and they don't get
Hmm.
paid.
It's not sustainable.
Only people that get paid are someone that works at Red. Correct. So the only way to get paid is someone working for, let's say, Red Hat. Red Hat is shipping enterprise Kubernetes to their customers, and now they need an incentive for them to keep it up to date. But Red Hat is going to introduce closed source features that is beneficial to Red Hat, but not open source features that's beneficial to the community because the incentives are misaligned. I think that's a big difference between open source that is centralized and open source that's decentralized,
Th-
and it's just not sustainable. And if you, the latest example with Stability AI, Imad is the founder. Stability AI makes Stable Diffusion, which is a very popular open source model, and they went to the traditional route of raising VC money at billions of dollars of valuation, and now they in the recent, Imad was out, kicked out by the VCs, and he was very clear, like you cannot do decentralized AI with a centralized
mhm.
model. It's just not going to work out. So he's exploring ways to sustain a decentralized system, a decentralized open source operation.
So that's very interesting. We have this idea on blockchains where, to run a network, to run a blockchain, you need validators, and then we incentivize these validators by giving them tokens. We had this since, in Bitcoin and Ethereum. It's not a new thing, but is um, but having them for developers and help actually incentivizing developers to contribute to a open source is something that maybe is a new idea here that we haven't seen, and this is something very interesting to me. Let's zoom out a bit.
I don't think it's a new
Mhm,
idea. It's been there. Ethereum Foundation obviously pays people to work on Ethereum. Solana Foundation pays people to work on Solana. The big difference between the Ethereum Foundation model is there is a foundation that's grants. That means there are a few people that are sitting in the foundation making those decisions. You don't know who those people are. It's not very transparent. Um, you know, well, maybe it is transparent if you know where to look. But for Akash, the model is on chain in the sense that the public goods fund. I think we have $15 million right now in the public goods fund. Uh, that anyone can go make a proposal, and there is a steering committee that reviews the proposals and posts opinions, not approvals, opinions on what the proposal could bring or could not bring to the network. And ultimately, the proposal goes on chain for token holders to vote, right? So it doesn't matter what steering committee thinks or doesn't think. It is ultimately the token holders, which are the stakeholders of the network, right? Ultimately, because that's really where the value capture and the good stuff happens. So I think like it's not a novel model. This existed in traditional world as well. I mean, you have co-ops and you have a whole lot of systems. It's just that on-chain is a lot more efficient and a lot more. I would say like a lot more efficient than your traditional models, right? And a lot more transparent.
Let's zoom out a bit and talk about Web 2 versus Web 3. For anybody who has worked in software engineer and in tech industries and in general in Web 2 companies, we know that how difficult it is to adopt a new technology, a new software and even changing from AWS to Microsoft Azure, even something that is very similar, represents a very big effort and a very difficult change for engineers, devs, departments, etc. Because usually there is a lot of effort and documentation and and skills, etc. So we generally say in business that for any business to make a real decision and change, the new product has to be 10x better. It could be 10x cheaper, faster, or something. Decentralized compute and GPU is a big trendy topic. My question is, yes, this is a new trend. We know that it has some advantages, etc. But do you think, and I'm not talking about Akash specifically, but in general, is decentralized compute 10x better than what we have on Azure, AWS, and other Web 2 alternatives? Or could it be 10x better?
Right now, it's no, right now. If you try to get an advanced GPU, be it H100 or A100, on Amazon, it's not possible. It's not possible. If you're an ML person, go to even Lambda or CoreWeave on demand. You cannot get. So you have no options. Forget better or not better. Forget all that stuff. Only place in the world that you can get on demand H100 for general purpose compute, in the sense running a model, any model on Hugging Face. You want to, like Grok, for example. Grok came out a few days ago. If you want to run Grok on demand, right? Akash is the only place in the world you can do that right now. Forget centralized, forget decentralized, all that side. Why? Because of the model. Because Akash can go places a centralized system cannot. Akash can go into companies, people that are having a bunch of servers sitting idle, that are not cloud experts, that want cloud capabilities to be able to sell their compute. Akash is the only one that can do that in a in a decentralized manner, right? And along with the crypto aspects of it, makes it extremely incredible because Akash being open source gives a lot more confidence on the provider side, because a big challenge for the companies is just not about, hey, we can sell some compute, but also how can we do so in a safe way, in a way that we have guarantees that it's not China that's taking a compute, or it's some state actor that's trying to hack into our systems. Because putting an external software into an internal system is scary, right? You don't want an untrusted software. So that's why open source matters. That's why people, or anyone that's serious about running infrastructure, do not run closed source software. Most servers are run on Linux, and most people know exactly what they're running in their infrastructure. So that's why open source is very, very powerful. It gives you guarantees as a infrastructure person. Um, and the way to sustain open source is decentralization. So one of the reasons why Akash is able to do so is because it's open source, decentralized, and can go places where centralized cannot. And there are about 750,000 H100s right now in the world, right? So there are H100s available. They're just everywhere. They're just, I mean, Mark Zuckerberg announced that they have half the supply of H100s in the world, right? On Meta. So that's 350K H100s. While the rest of 350K H100s are with companies that are everywhere, right? Not Amazon, not Google, Microsoft. These companies, Akash gives these companies a way to lease the unused H100s, because a lot of times you're also in between
Mhm.
training runs, or when you completed a training run, you want to do inference. Inference can be done on a cheaper compute. So someone else can use your H100s, right, for training. There is a new trend now in AI called where you have smaller models that outperform larger models, like GPT-4, like ChatGPT forgot
Mhm.
how to code, because Mixtral code is way better, or like their other coding models are way better that's smaller. So there is this new trend of, hey, we don't need to train a foundation model on you know 300,000 H100s, but we can, if we get an 8x cluster of HGX H100s with high interconnect, it's great to train a model, expert model. So as we get into the scenario where companies are training smaller models and smaller clusters and getting access to even a decent chunk of 800 H100 is extremely challenging. There is a story recently on Semaphore, which is a very popular magazine, that talked about how a Columbia student was trying to do machine learning, and they wouldn't be able to get it on um, on um, on Amazon's or Google. So only place they could get was Akash,
Wow.
right? And that story is we're starting to see mainstream media picking up quite stories like this. There's a story yesterday in Fierce Electronics about Akash, and how it's just the Akash right now can offer H100s for $1.49 an hour, which is the lowest in the world. And if you look at Amazons of the world, I mean, if you're lucky, an Amazon H100 costs $12 an hour. If you're lucky to get that, and they don't have them anymore, but that's the price they're selling if they have them, because the centralized structures are breaking right now. Right? It's not for AI
The
especially.
decentralized compute space is evolving very rapidly. We are seeing almost every week new protocols launching. I've recently released a dashboard on AI sector, and it already has like more than 20 protocols that aim to work on decentralized compute. What is the differentiator of Akash here within this sector? Akash is actually one of the oldest projects, decentralized projects, working on that topic. But I would like to hear from you what is differentiating Akash from all these new players.
Everybody wants to be Akash, and Akash is the first one. So if you're asking me why is Akash different, I think the question should be on the other protocols. How are they better than Akash? But what I can tell you, I don't want to go into specifics because it gets nasty. And I'll make this bold claim to be challenged by anybody. Um, Akash is the only permissionless and open source network that's general purpose, in the sense a lot of the new networks that have outsized GPUs cannot run most models. They're very limited uh, in terms of what they can run,
In which
right?
sense?
Like you cannot run a Grok, for example, or you cannot run Mistral. Mistral is a very popular open source model. Try to run that on any of these new networks that came out. None of them can run Mistral. Um, they Most of them are closed source, so we don't know what's happening underneath the hood. And there's questionable metrics in terms of how and where they source the GPUs from. There are two categories, I guess, of networks. One category sources GPUs from consumer GPUs, which are not very usable for machine learning, right? You can do like very, very small experiments in the consumer GPUs, but anyone doing serious machine learning cannot use consumer GPUs. And then you have um, another network that's bigger than Akash could be Render Network, right? So Render is
Hmm.
exclusively for rendering. They're not AI capable. They do have 4090s and lower end chips, but no H100s or A100s. And Render, again, it's not permissionless and it's not open source and all that stuff, right? All that set aside. But in general, from a capability standpoint, they support one model, I believe, Stable Diffusion, whereas Akash can run 30,000 models on Hugging Face. So the big difference is just capabilities, right? Um, like Akash is general purpose and full stack in the sense like when you are a machine learning dev, it's just not getting GPUs that's going to solve your problems. It's also getting the disk, the memory, the bandwidth, the ability to attach network storage, the ability to get an IP address so you can communicate, the orchestration, granularity in orchestration. How do you connect two different services? There are quite a lot of capabilities one would, and good CPUs too. You just can't just have GPUs without CPUs. Quite a lot of like capability wise that you need beyond just a GPU to run a production grade workload in terms of fault tolerance as well. So Akash is the only one that can provide you all this. And another closest network that would come to Akash is Flux, I would think. Flux has been around for a long time. So I would give them credit. And they are definitely building good stuff. The only big difference between Flux and Akash is Flux and Akash are both open source, by the way, is Flux is still permission when it comes to deployment. So you need to get an approval from a DAO for any application you want to deploy. Akash is fully permissionless. There is no approvals or any of that stuff. So I would say Flux would be the closest that would come to Akash in terms of capabilities wise. But every other networks are either very limited in what you can do, and some of them are launching with big numbers. So, but the amount of stuff that's usable is very little in
I
those
did an
networks.
interview with Jason from Flock actually just 2 days ago, so interesting to see get confirmation from you. But just to clarify one point, because maybe it's not clear for everybody. When you say open source, so we anything that is on chain, a smart contract, anything, this is open, right? You can see the code, etc. So when you say open source, do you mean that there is some kind of orchestration or something like that happening on off chain that needs to be done, and that most libraries are not don't have any open source library, meaning that you don't know what's happening actually, and how the orchestration and how the assignment of different GPUs to users are being done, and Akash is actually has open source this, so anything that is happening on Akash can be actually tracked and seen by anybody and contributed. Is that the point you're making?
Every piece of software that you use at Akash is open source. So your web interface, for example, console or Akash is open. The
Wow.
website is open source, right? So you know exactly where the data is coming from. You know exactly what's underneath the hood, how it gets scheduled. You know exactly that no one is prying on your privacy. You know exactly there's no manipulation in terms of prioritization. Uh, and you have an issue, you have a bug, you can go trace it back and be like, okay, this is the problem area. And if you have very capable engineers in our community, then they discover a problem. Sure, they file an issue, but more importantly, they come and fix the problem, right? So you get that community participation when you're open source. But I think from a security and privacy standpoint, open source, I would not, anyone serious about infrastructure would not touch closed source software. One of the reasons why Akash is being used inside of Department of Defense, US Department of Defense, is because of its open source nature. There's a public um, comments, or there's an interview by a Marine Corps officer that implemented Akash internally, and they gave a whole sort of like presentation on how they did it and why they did it. It's a very, very incredible presentation, or a conversation that you can get a lot more details. But more important, they were like, well, the privacy Akash provides and the guarantees that there is no middleman, or there's no one looking at you or scooping on you. That's guaranteed by code. Is very attractive for U.S. Department of Defense. And if it's good for defense, I think it's good for most people, right? So It's just the, you know, to you can be closed source, but you need to be someone thing like in Amazon. Even Amazon, there's no the
Yeah,
lawsuits. I don't know if you know about this, but a lot of lawsuits on Amazon on like people complaining that Amazon doesn't give them what they need, and most of them are settled out of court. But there's quite a lot of issues with Amazon that you don't know what you're getting, right? Akash, you know exactly what you're getting, and you can go verify the code. There's absolutely, and there's discrepancies. You can point them out, and we actually encourage folks to go
maximum
fix it, right?
transparency.
So that's sort of like radical
Perfect.
transparency, I call it, including like code. Code is one part, right? Code being open source is great. I mean, every decentralized software, be it Ethereum, be it Solana, be it any successful software is open source. Um, it would not be considered if it's not open source. And I don't know how you can say something is decentralized when it's not open source. I mean, it's just a really bothers me quite a lot. Um, yeah, unless you're doing ZK, which is the only reason, only place where you can be like, okay, you don't need open source because
Hmm.
it's proof.
Yeah.
There is there is a proof that's generated using cryptography that can be bypassed as like, okay, you don't need open source there because there's other ways to verify. For general purpose, I don't think you can do anything
Yeah, by the way,
without
there
open
are a
source.
few projects working
Um,
actually on ZKML and ZK, zero proof, machine learning trainings. So that's also another sector, projects like Modulus and ZK and Giza and EZKL. That's also another sector. But let's talk about that. That's interesting. What kind of subsectors are you seeing in the decentralized GPU sector? Because it's becoming pretty big. Some are already saying they're focusing on gaming, etc. What kind of trends do you see within this ecosystem?
the big trend is just compute, right? Akash was the first one to do this, and we have a lot of clones now launching with Akash. Each one of them having their own like why they're better than Akash, I suppose. But Akash is the only one that's being used in life. It's the only one that has a real life product, and you'll see a lot of examples in the wild. If you just go to Twitter and type Akash or Akash SuperCloud, you'll see a lot of people using Akash, right? You'll see users in the wild. Um, and you don't see users on the wild for any other networks except the people that say that they use them, like the networks themselves. Uh, and then you have
Hmm.
verifiability. So the Gizas, like you said, the modulars, verifiable machine learning is also very interesting. I like Jensen. I like
Yeah.
Giza is pretty interesting. Um, uh, I believe Ritual is another attempt at verifiable. They're taking a more optimistic approach. Um, and then you have BitTensor, which is like the orchestration layer for AI. I would say. I mean, everybody has their own definitions of BitTensor, but my personal opinion is it is a incentivization layer for um, AI models and AI services. Through incentivization, it provides orchestration. So it can bring all those together. It provides a layer to distribute to distribute these incentives and creates a common currency to interact. And we have gaming is another interesting aspect. We have quite a lot of games on Akash now. Passage is a very metaverse. Gaming is another area. Passage is a classic example deployed on Akash, where they're using GPUs both for
Hmm.
AI as well as rendering, right? I mean, 3D rendering. Stable diffusion is getting very popular with game designers as well, and in-game character generation as well, which is fascinating, right? Um, I think those
And
at a high level you'd say be considered in the
before
AI
diving more
sector.
into specifics of Akash, we mentioned about some competitors and they are doing large numbers, and some competitors, without giving names, but they are saying that they have like 350k thousand GPUs, um, consumer and non-consumer, etc. What do you think about this? And is Akash going to compete in that sector of maximizing number of GPUs, or are you more going to provide a framework and an infrastructure rather than just maximizing the number of GPUs and the number of these kind of metrics? What is Akash optimizing for?
Unfortunately, a lot of this number of GPUs only matter if they're usable, right? So, what's usable GPUs mean? So first off, there are three types of things you can do with AI. First is training. Training is the most computationally intensive activity. And training is limited by
Mhm.
latency between chips, in the sense how fast the neural network can pass messages between neurons. So basically, the chips, right? So the neuron here, two different chips, how fast they can communicate. And there are on chip memory, which is also another big factor. 80 gig memory can train larger models, smaller memory size can as limited to training, right? So you need a lot of memory, a lot of uh, very, very
Absolutely.
good connectivity
Low
between the
latency.
chips. So that means low latency, right? Uh, that means you need large local clusters, and those large local clusters are not available with consumers. Consumer chips are very isolated, individual chips. So these chips cannot be used for training, and they cannot be, if you're not using for training, well, what can you use them for? Inference or fine tuning. Well, for fine tuning or inference, another factor is external connectivity and consistency and performance and connectivity, along with storage and cloud capability. In the sense, if you have a home computer, that home computer is not optimal for serving on the internet because connectivity is questionable, and power as well. You can't run a powerful GPU for X amount of time without tripping your home residential power limitations. Um, a GPU right here behind me is a 4090 that consumes about 450 watts of compute, right? Or of power. So that alone itself is quite a lot
Yeah.
for a home, right? 450 watts. So if you have, and that has a 24 gigabytes of memory. So my question to you is like, sure, we can bootstrap compute using incentives. I mean, that's not a novel, endeavor. We saw what Helium did by bootstrapping 300,000 devices, what Filecoin did with bootstrapping storage. Using crypto rewards is easy to bootstrap compute. Um, but the question is, what does the demand look like?
Exactly.
How do you really use a compute? Is there demand? And we don't think there is demand, and we just, because we haven't solved the latency problem with training. In fact, there is the most advanced research in this arena came from Google DeepMind. They published a paper in December called Doloco paper. That seemed very promising in terms of leveraging uh, GPUs across the globe. And this is still in very, very early stage research, nowhere close to implementing. No one has done that before. So when protocols are claiming that they have solved latency, which is physics, right? This is, latency is about how fast light can travel from place to A to B. Um, I find those claims questionable. Unfortunately, crypto is one of those
Marketing
areas
is
where
important.
headline matters more than the details. Sure, marketing is important, but the mentality also got us in trouble not too long ago. In terms of marketing the wrong things is worse than significantly worse than not marketing at all. Because if you're going and telling the world that you've solved latency and heterogeneous training without actually showing how you solve, without writing, without publishing anything, um, except making claims, that brings a very, very bad name to our industry. And this industry is already struggling quite a lot to stay relevant. And through the bear market, we didn't have this noise people were building. Now the bull market is back, we begin the noise. So just be careful out there is my only advice. And there are legit projects, obviously. I mean, Bittensor, Jensen, Ritual, a whole lot of others that don't make such claims. And then there are projects that are closed source and showing big numbers and impressive numbers. Of course, if you say you have millions of GPUs, people will turn heads, right? Of course. Ultimately, we don't know where the GPUs come from. We don't know how many of them are real or not. We don't know what's underneath the hood because it's closed source. We don't know anything except a number we see. Um, we don't know what the demand looks like. So I would highly recommend people to do their own due diligence, or depend on someone technical to do due diligence. Use the products yourselves, make the judgment yourselves. Do not trust a claim. Trust but verify is what I would suggest.
I think you made a great
But
point
always verify.
about the demand side of the things, where on the consumer side GPUs, for anybody who has done any kind of data science work, they you know that what you're looking for is training is already takes a lot of time. When you are training multiple models, and you have to always optimize and change your parameters. So this is taking it takes a lot of time, and so companies and startups they want the lowest latency possible. And if you have one computer here and one computer in another continent or another country or even another city, then this is will become really hard to actually to sell to any kind of startup. Maybe a student will use that, or maybe some small entities or persons, but it will not there will be no demand for such kind of high latency solutions. And so I agree that this is a great point. Let's talk about pricing. There is some claims, including Akash, of having up to 80% like cost saving compared to Web2 players like AWS, Azure, and GCP. Usually, the way that pricing, at least in my opinion, works is that as you scale, as a company scales, the price is lower. And we see that, with Tesla, for example, that started with very high, car models, because they couldn't produce thousands of them. And then as they grow, and they optimize every part of the thing, the prices get lower and lower. How can Web3 solutions like Akash and others who are making these claims offer up to 80% cost saving compared to giants like AWS and Azure, who have hyper optimized data centers and GPUs, etc.? Where is this saving coming from?
Well, the first point to remember is Amazon, Google, Microsoft, they're middlemen. They don't make the GPUs. GPUs are made by NVIDIA. In fact, even NVIDIA doesn't make the GPUs. It's TSMC. NVIDIA is designer of the GPUs, and TSMC manufactures GPUs, right? So the cost NVIDIA, Amazon pays is similar cost that you and I pay to NVIDIA. That's point number one, right? And point number two, Amazon needs to make a profit, right? When they purchase a chip from NVIDIA, they need to add a margin. If you look at Amazon's margins, they are 70% or something crazy, right? So they need to make money. And third is in the money factor, well, Amazon purchases chips to be as a commercial venture, as a return of investment. Most chips on Akash come because they're not used. It's a machine learning company that, for example, uh, bought A100s 3 years ago and used them for training the model. Now they upgraded their fleet to H100s. They're sitting on this big batch of A100s that are not being used. And they will get anything, they'll take anything that they want to pay, they can get versus not. So now the cost is, since Akash does a reverse auction mechanism, it's an auction. So the chances of this company winning or making money is higher if they can quote lower prices. And for them, it's a sunk cost anyway. And they've probably used the A100s to their maximum potential for whatever endeavor they were involved in. Now it's just about getting what you can get, right? And similar, the same economics as Airbnb and hotels, right? Hilton versus Airbnb. The reason you can get a cheaper price on Airbnb
Sometimes, yes.
sometimes is because there's a lot more inventory. And now again, sometimes not, because when there's low inventory, you might get higher price. Like in Akash, for example, not everything is cheap. Some chips are actually higher, a lot more expensive than Amazon. because the demand is higher and supply is lower. But what's important is the price variance is completely transparent. It's demand and supply, right? So the more chips we discover uh, that are hidden in places where typical Amazons and Googles cannot go to, we're seeing. We just saw an offer for 1,000 H100s for $1.30. Someone's willing to offer that to Akash because they bought those chips from a company that an AI company that raised a lot of money and bought the chips and now running out of money and they had to sell the chips. So you can get places where you normally traditionally cannot go to, and this company was bought the chips and they can't go to Amazon and be like put the chips on Amazon, right? Because Amazon doesn't have a model. So you have that's the reason I said Akash can go to places where Amazon can't, so you can get significantly lower costs. Again, it's not
based on supply and
guaranteed,
demand.
right? Nothing is guaranteed. It really comes
You
down
mentioned
to correct. And Akash doesn't make any super claims like 90% cheaper. Like maybe just
you,
say it's cheaper. It depends, right? The other
you
people
mentioned
that
about
make those
brutal
claims.
transparency and honesty. Just a side question: does Akash provide information about where his GPUs is coming from?
Oh yeah, go to stats.akash.network, console.akash.network. Go to akash.network/GPUs. You'll see exactly where the GPUs come from, which providers. You can see Foundry Staking, which is a DCG company, which is a
Okay.
big provider on
And
Akash. You can see
so
quite a lot.
Akash is not going for consumer GPUs, right? If I have my computer here with unused GPUs, because you cannot optimize for latency, you're not sourcing it. I cannot provide my GPU to Akash. Is that correct?
You can. I mean, as long as there's someone that's willing to use your
Okay.
GPUs. I mean, Akash is an open marketplace. You can provide anything. I can provide my laptop if you want.
Who will use it?
But the question is, why would a company use your laptop versus they can get a better chip
Mm-hmm.
on Akash in a data center? I mean, Akash, anyone can sell anything as a marketplace. It's permissionless. So there's no stopping. There's no limitations. Nothing you cannot stop anyone from using Akash. So, but let's say you have a 4090, like I have my 4090 now, right, right here behind me. That people want, and I'm offering that at 10 cents an hour, right? So people want 10-cent inference. You may not be, you don't sometimes you can do an asynchronous inference job where you have essentially a pass-through server that'll, you know, not to get into technical weeds,
Yeah.
but you can do an asynchronous call versus a synchronous call where it's less sensitive to latency, asynchronous. Um, there is that opportunity as well for the right price, right? So I'm not saying it's not possible. It's just the type of applications right now that are being built, considering AI is very slow. The inference calls are very, very resource intensive. Even now, um, it it's detrimental to have that extra latency, right? We hear that quite a lot from different people because the inference for stable diffusion, for example, if it takes 4 or 5 seconds, or chat is even better. Like if the inference for a chat takes you know one
Mm-hmm.
second, which is a lot. Imagine waiting for you ideally want 100 millisecond response times for cognitive continuous. That's the standard set by Gmail when Gmail is fast, right? So Paul Bocad and a lot of industry folks that agree that every interaction should return within 100 milliseconds for it to feel cognitively continuous, no lag, right? Anything over 100 milliseconds means 1/10 of a second, feels lag. So if your inference for chat is taking about a second, it's still very slow. And then your latency that you add is adding another second, then you're doubling, and that impacts your performance, right? So take all that in account. So yeah, maybe in the future when models get faster. In fact, it's quite a lot of research now with Delacoe and whatnot, where they talked about data islands and like interesting stuff that's happening. Maybe in the future, yes, consumer grade GPUs could be helpful, but right now it's still
Let's talk
very
about
early to
this
say.
latency and follow up on blockchains. Um, if you remember with GameFi, when the first game on-chain games came, like Axie Infinity, there weren't a lot of on-chain thing. So the game was not on-chain. The only thing that was on-chain was buying and selling the NFTs and these rewards and the tokens and incentives. But most of the things and the game itself and the and everything in between was not on-chain. Now we are seeing a new generation of GameFi where we have much more on-chain stuff happening now. Also with the scalability that we've got in the last years, it also helps a lot. But we are now, there is this new generation of games that are now fully on-chain games has become a new trend. Now, drawing a parallel with AI, I know that a lot of these AI projects, web3 AIs, don't have a lot of on-chain things. So maybe they provide incentives to the GPU providers as tokens, and that's on-chain. There is we can track that. But we also talked that its inference and training is already really slow. So what do you think can we achieve in terms of going? And we like on-chain because it's maximal transparency and trustability and all these things. Where do you think can we go, and what trends are you seeing, and how is Akash positioned in terms of seeing the on-chain? And I would add one thing is that many of the AI projects are just protocols, but Akash went through a more complicated route of building on a Cosmos SDK. So you are actually a chain, and this has a lot of technical overhead. But maybe you can elaborate on that choice, and maybe the ambitions that you had, and if it's related to this on-chain topic that I mentioned.
So to summarize the question, are we going to see AI on chain? Considering the trend right now is chains are only used for tokens and token related aspects, but nothing beyond that. So first of all, I think trace back a little bit. Why do we need on chain? Why is even blockchain a thing? On chain is when you need a blockchain is to simple terms, blockchain is a database anyone can write to. Okay, that's where a blockchain really is useful. Beyond that, it's useless. It is one of the worst databases in terms of performance. It is, immediate consistency. That means it slows down. You have verification overhead. You have quite a lot of aspects that are that is expensive from a computational standpoint that you have to perform to enable permissionless writes. Right. So you can't put everything on chain. Doesn't make sense. It's like if you design an application, if you put everything in a database, including your images and videos, you're screwed because your database gets really, really large, right? Even though database might be easier to extract and retrieve and all that, but databases, like traditional databases, are good for relational data where you have to query relational aspects, right? So you have to use the technology for what they're good for. And it's not, you cannot make a general sort of like claim that everything has to be on chain or things have to be off chain or any of that stuff, right? So you got to use stuff that makes sense for that particular problem. What is a problem you're trying to solve instead of trying to say that there is this technology, why is everything not on the technology, right? So in that sense, for Akash's case, most stuff on Akash is on chain in the sense the coordinate on chain is a coordination layer, whereas compute is off chain. Compute execution is off chain, right? So the way you get resources in the sense like the bidding, the order book, the tokens, the leases, all those are on chain. Everything is on chain. But the moment you acquire the compute, it becomes peer to peer between the user and the provider. There is no on chain. It doesn't make sense to go through on chain. It's just no overkill to use on chain. And the chains are not, because of the verification overhead on chain and the limitations in data availability, you you are not you should not store large objects on chain because that gets, let's say there are 100 validators on Akash, and we're talking about 100 validators maintaining a copy of that large object, right? Um, but what you could do is store that large object in a place that's hopefully decentralized and use that and place that reference to the large object into the chain. So the chain becomes much lighter. So you always want to keep the chain as light as possible because these chains have to live for a very, very long time. These chains have to live for hundreds of years. So if you start adding stuff to in terms of increasing the size of on chain, you challenge the longevity of the chain. So chain should be very, very conservatively used, and only thing that makes sense to put on chain, you should put on chain. Putting a model on chain doesn't make any sense at all. But can you put a proof that a model is real? Yes. Right? So all you need is a proof. Like, for example, if I have a model file, if I have a file, right, and I take a hash of the file, right, and I put that hash of the file on chain saying that, hey, this file needs to match this hash to be legit, and I sign using my wallet address, my account, right? Someone else puts another in creates a hash of a different file and tries to verify that on chain. It's not going to verify. So it doesn't matter where the file is stored, as long as the file matches the hash, then I say this is the real file. So chain should not store the file, but it should store the hash of the file. What I'm trying to say is, like, you should, putting everything on chain doesn't make any sense, right? But access to the compute and uh, and references and all that and the coordination layer should be on chain, right? So Akash chose Cosmos SDK because we began with Ethereum in 2016. Ethereum Frontier was called. This is before the smart contracts came in Ethereum. I mean, right around the time smart contracts came. And we actually developed it on Ethereum, and then CryptoKitties launched, and it crashed the entire network. This is in 2017. And that became very obvious to us that Ethereum was not the network to do scalable protocols. And the question about, do we need shared security or do we need sovereignty with security? At that time, even now, as a matter of fact, shared layers are not scalable. There are inherent limitations. Now they're talking about L2s and I guess L3s now. But those L2s and layers, so these are abstraction layers that were created to solve for the lack of scalability in the fat chain thesis. And that's just a bad pattern, right? I think layer one should be scalable by default, or go to something like sovereign chains like Cosmos SDK.
You don't
chains.
really believe in the,
and Akash is the first Cosmos
in the
SDK
modular
chain,
thesis,
right? And we're the first one. What's that? So thesis and all that is good, but what is real and what is theory is good, sure. But when it comes to practicality, is it real or not? None of this stuff is real yet. They are toys. They're not being used at scale. They're not anywhere close to validation that people claim to have validation. Very promising, right? Like I told you, like, I helped launch Firebase at Angel Hack. I never used Firebase. I never would use Firebase because it was shared resource plane. Any senior engineer would not use Firebase because you lose sovereignty. And sovereignty means you can't do so many things that you can normally do. But Firebase came to a point after 10 years of hyperscalable database and that I would use today. But it took 10 years for Firebase to get here. And similarly, this space is so early to pick a shared state chain or modular chain, whatever you want to call it, and prove that it's scalable for large deployments. And that's going to take, if it took 10 years for Firebase, I don't know how long that's going to take for decentralized systems, because decentralized systems might take much longer. I mean, I love Solana. I've been a big supporter of Solana from day one. In fact, if you go to Solana's YouTube, my first videos of me and Anatoly from 2018. So I've been a big supporter of Solana. But even Solana at scale, during high traffic times, it's just very slow. We haven't solved that problem yet, right? I mean, it works most of the time well, but it does go down quite a lot. And if you're going to build critical infrastructure on something that's not reliable, you're never going to see that infrastructure successful, especially something that's using machine learning. So sovereignty was key for Akash in order for us to even get to market, because without that, there is no product that's usable. And that's the reason why Akash is the most used decentralized AI product with real revenues, tracking right now at $1 million run rate. In none of the other software, I mean, I guess the newer ones don't even use on chain because they just they, there's nothing decentralized about the new protocols that came. They just use the tokens on chain, which is not really using the blockchain for what it is supposed to be. Uh, it's just not there. If you want to create a truly decentralized system, you cannot build with anything that's out there except running your own chain, and that's either using Cosmos SDK or Polkadot's SDK and the
Let's talk
CDK
about
from
and conclude with
Polygon and those guys.
evolution of protocols and lessons learned from the past. I think, from what I know now, I think Akash is probably maybe one of the top three AI related projects that are pretty old in AI, in blockchain. So most of the, 95% of what new projects that they call themselves like AI related, they are pretty like they are 5 6 month old, most of them. And even like older projects like Fetch and Singularity and Ocean, they are not that old. What So you've been actually through even two bear markets, not just the 2022 one but also 2018. What lessons have you learned from and I'm not talking about the AI sector, I'm talking about crypto and web3 in general, from these challenging moments as a protocol?
One biggest lesson I learned over the years is do not trust closed source software that's masquerading as decentralized network. Just don't. FTX was one. Celsius was one. They all seemed great. They all have great advisors, great board. They all seem really, really very promising, great team, all that stuff. But because they're closed source, we trusted too much in this closed source and we got hurt. Uh, I honestly believe this is the last cycle for crypto to get it right. If we don't get it right this cycle, we will die. Um, and what that means is this death by regulation, this death by lack of consumer trust. You have two big risks for AI or crypto in general. Death by regulation is when you have so much fraud in the industry that the regulators or the legislators will have enough ammunition to shut down the industry. And that's happening right now, right? This FTX was a big catalyst for that rhetoric. And we're starting to see that again with meme coins and a whole lot of like pure gambling, pure speculation aspects of it. And that also breaks consumer trust, right? Because when someone serious wants to get into crypto and they're here because the promised land makes things better. Now you see meme coins that are, I mean, fun, nothing wrong with meme coins, but the moment that fun becomes fraud is when challenges start coming out. And we're seeing a lot of fraud now. Uh, in meme coin like culture spreading to other protocols where the airdrops and all the make noise and
Pumps and dumps.
you know get famous and follow the meme coin mechanics to yeah to go to market, all that is, I think, is very, very dangerous for our industry. This is the time we in bear market, as we were getting out of bear market, crypto AI was starting to take off a little bit. It was very promising, right? We had real world assets, we had crypto AI, even DeFi was getting, the DeFi 2.0 was getting to be really good. The yields were optimizing. People are starting to question where the real yield comes from. All the good stuff was happening very well. And of course, we expected greed to come and a lot of new projects. When you saw AI take off and Akash, all that success, you're going to see clones, right? That's a given. But I think people are so crazy in this meme coin mania right now. People are forgetting why we are here for, what we are here for. We're here for systems that we can trust, but we also need to verify, right? And as much as I'm a big supporter of Solana, I'm seeing a shift in culture in Solana ecosystem where even the major projects are closed source now, right? On Solana. It's very disturbing because I know Anatoly is a very open source. He values open source software. Solana in itself is open source. The actual node and whatnot. It's a good amount of
Hmm.
projects that are very open source in Solana, but the new trend is closed source because people consider it to be competition. I'm like, well, you're building open systems. If you come to building open systems with a competitive mindset, you're going to end up creating companies, not protocols. Protocols are supposed to be protocols that improve upon each other. And they're legit projects like BitTensor and whatnot that are fully open source and incredible, right? In AI, but watch out for people that are just coming to the stage with no white papers, with no documentation, with no explanation as to how the systems work, a UI with questionable numbers and all that stuff is just going to be very dangerous. And a lot of KOL rounds we're seeing, a lot of people investing, raising money from influencers so that these influencers will go promote these tokens because there is a now they have incentive. I'm just worried this new model is going to get quite a lot of regulators to make even stronger cases, right? There's going to be, I mean, I'm just worried for our industry. So I'm actually going to DC um, next month to Congress to meet with senators and congressmen, and we're doing quite a lot of work and trying to push crypto forward with us along with Coinbase folks and a whole lot of folks that have been in the industry for a long time now. It's getting increasingly difficult to represent this industry that's written in fraud, right? So uh, we have two major attack vectors that we need to solve for, or else we'll die, which is regulatory attack vector
A
and
few follow-up
consumer
questions.
interest
One
attack
is
vector.
regarding new projects and open source versus closed source. I agree with you about the fact that we are in a decentralized, industry, and ideally everything should be open source. As a founder perspective, if you want to compete and everything is open source, and we've seen already forks, fork is a narrative on itself. In we've seen, there are thousands of forks of Uniswap and Aave, etc. How do you even compete if everything is open source and everybody can copy your work? So what is the edge to have for a not a company, for a protocol, actually, if everything is open source?
Well, the edge is why are you even doing a software when there's something else? Ethereum, Uniswap is the most successful decentralized exchange. Why? Without incentives. They don't even incentivize for liquidity. Why? Because the first one is the open source one. Are there better Uniswaps? Questionable. Well, someone just copied Uniswap and, you know, dropped a bunch of tokens, but why? Why do you need that? Right? Like Uniswap is still successful being open source, right? Like Kubernetes is still the most successful project. There are lots of clones for Kubernetes. If the clones are doing something better, I think that's great. And they should be open source, right? But if the clones are just clones and nothing better, they shouldn't exist. It's just that's not what we're here for. You may as well take a position in open source in Uniswap and actually develop on Uniswap and engage with the community. It truly open systems are welcoming, right? Anyone can make, like right now, Akash has $15 million in the public goods fund. If you have an idea to build a better Akash, you can go apply for the fund and get funding, right? Like it's permissionless, like, but make a case, make a strong case that no one can refute why you are doing an improvement. And there are lots of, I mean, I can tell you a million problems right now with Akash that needs to be fixed, right? As a founder, I mean, go fix it, get funding. And even I can't stop you. That's real decentralization. So code can be open, code can be copied, but community cannot. You can fork the blockchain, but you cannot fork the community. And crypto is not about just products. It's about community that uses products and this community owning the product that they use. That's what crypto is for. It's the shared ownership, is the common that is powerful than a corporation. Yeah, it is the free market. And for a free market to truly function, information asymmetry needs to be destroyed. Everybody needs to have same amount of information that everybody has in a truly free market, right? for a the difference between decentralized systems and centralized systems that people don't understand, that a lot of new players that come into the market don't understand, is open systems are like markets. And the success scenario for a market is equal participation and perfect competition, we call it. In fact, perfect competition is when everybody offers the same thing and you have perfect competition. The consumer has the perfect sort of like price, right? There's no one, giving you wrong price. Whereas, and that's great for the market, great for society. Whereas a corporation, the best outcome for a corporation is a monopoly. Like a corporation is considered to be successful if it has a monopoly. Like Nvidia has a monopoly on GPUs right now, A100s, right? I mean, Google has monopoly on search. I mean, that's why they have antitrust. And anyway, the success scenario for a company is monopoly, where the company extracts as much value as possible from its users and distributes the value to its shareholders. There may not be its users. That's the difference. So you cannot act like a company and talk about competition, because that's for companies. You got to act like a market and talk about information, or shared prosperity. And that's a mindset I think people need to change. And that's why people say, oh, if I'm closed source, how do I compete? Well, why are you even trying to compete? What is your competitive edge? What is something that you've discovered better? Why don't you write a paper about it? Why don't you have community, your peers review the paper and accept? Because you're building decentralized systems, you're not building corporations here. Nothing wrong with building corporations. Go do that. Do that closed source all day. In fact, with closed source companies or closed systems, you can go much faster than decentralized systems. But with open decentralized systems, you can go much further than closed source systems can ever reach. And we are here to build those systems that go far. And that's why the valuations are outsized compared to your traditional closed corporation valuations, because the reach and the impact for a decentralized system is so high and significantly exponentially better than anything that's closed or centralized. And that's why you have these valuations and all the good stuff, right? So if you're trying to compete, do
Very
that
powerful
with
statement.
corporation. Don't do that with the protocol.
Powerful
Unless you have
statement.
a
Let's
very
conclude.
strong, very
We like
strong
to
reason to
conclude
compete.
with a hot take. Just this morning, I tweeted that I think personally, for Web3 and crypto to go out of speculation, which is now a big part of it, uh, potentially three narratives I think can bring that. One is real world assets and adoption from institution. One is GameFi, and because the gamers and gaming is a very big industry, and the other one is AI and startups and devs, etc. What is your take on that, and how where do you think adoption will come ultimately to get to a billion user?
Good question. I don't have a strong take on any particular sector that's going to overperform the other sectors. I mean, that we don't have enough data to back that up. All these three sectors you mentioned are extremely small right now, compared to even meme coins, as a matter of fact. Uh, Even meme coins could be considered as a sector when you compare meme coins to lottery, right? I think you winning a meme coin in a meme coin scenario is significantly higher than you winning a lottery. So you can consider that to be a mainstream sector as well. Uh, so I like, if you look at true, so systems like compute networks like Akash, they're not consumer um, systems. They're for other developers to use Akash, right? Um, so consumers are not going to be using Akash directly, but people are going to be using systems that are on Akash, right? And real world assets, I think, is very strong case. I would say, like mortgages, right? For example, breaking up mortgages into smaller pieces and all that. There is a strong correlation with consumer potential there, and games definitely are very consumer potential, right? Like, so if you were to really put it, unless you have verifiable machine learning, which is very interesting, by the way, that could be a consumer grade play, but infrastructure like Akash's of the world are not going to be the billion users. I mean, Akash, what has 100,000 wallets, right? Unique wallets right now. and that's not anywhere close to a consumer grade like chain. And a lot of these wallets are developers, right? Like people that use Akash. Um, and I would say a lot of the wallets would be just people that don't even use Akash, right? So people just hold Akash. So and a lot of these holders are we either using Akash for what's supposed to be used for developers or use speculators at that point. So these two are not the use cases that are going to onboard a billion users. I would say metaverse, I would say gaming, I would say real world assets, even DeFi, as a matter of fact, has a higher chance of attracting the real world people. NFTs had a great shot, but then like I actually like NFTs now that they are less speculation and more about capabilities. um, just putting digital rights or contracts on a blockchain is phenomenal, right? I mean, there's immutable contracts, right? My land deed should be on a the deed should be on a chain. I mean, why is it that every time I need to verify my deed, I need to take paper and just navigate through extremely complicated systems to even get to the deed? So a lot of these aspects could go on chain, right? So the real world aspects, I think, is I'm fascinated by that by the implications that they bring. Yeah, that's where I stand. Unfortunately, I don't have a single exciting pick for you.
Great. Thanks a lot for these insights and everything you shared, Greg. That was very insightful. And wish you all the best for Akash.
Thank you so much. This was very good.